Good evening, everyone. AuthorCafé team welcomes and thanks you for being part of this two-day virtual summit, where multiple aspects around the PhD programs are going to be discussed, particularly in the context of Indian research ecosystem. To begin today's discussion, I would like to invite the chair of the summit, Dr. Savita Iyer, a life scientist with her PhD from University of Cambridge, UK. She's been very active in the Indian research ecosystem for more than a decade, with her focus being on the research management. In fact, she has the credit of establishing the first research office in the country. Savita, it's a pleasure to have you chairing this session. Over to you.
Thank you so much, Neil, for that introduction and for opening today's session. I'd first like to thank AuthorCafé for convening this exciting summit on PhD programs. It's a real pleasure to be here amidst all our eminent panelists and colleagues. Just a few minutes to share some housekeeping instructions first. So today's edition of the summit will include a panel discussion and a latter part where we can take questions from the audience. We request our attendees to put your comments and questions for our panelists into the Q&A box on the platform. And please do also share your thoughts and comments on the summit. If you're tweeting about the event, please use these hashtags in your tweets. We'd love to hear from you. So on that note, I would now like to say a few words regarding today's PhD summit. So research conducted by PhD scholars forms an important part of the overall research output for India. Our PhD scholars are amongst the brightest in the world and are the scientists, innovators, problem solvers, and leaders of the future. And institutions make significant investments in attracting, training, and developing the best students for their graduate programs. And from a PhD scholar's point of view, the period of graduate research is a long process of learning to be a researcher. This learning journey for the student is made possible both through their own work and also through the work of a large number of other professionals. So there are mentors, collaborators, and peers who obviously play a very crucial role, but also our institutions and funders play a very important role as well. So in our summit, we are delighted to be joined by a group of very eminent panelists who between them have worked across a wide range of public and private institutions, both in India and overseas. Our panelists are researchers and research leaders, and through their eyes, we hope to gather some fresh perspective on PhD programs in India, especially with a view to the future. What role do PhD scholars play in the Indian research ecosystem? What practices can help institutions nurture their graduate programs and students? And can emerging technologies play a role in facilitating the management of PhD programs? So these are some of the questions that we hope to address during this summit. And today's edition of the summit is focused on understanding the role and qualities of a successful PhD program. And yes, we take a look at this from the perspectives of our eminent panelists. So on that note, let me introduce our panelists for today. It's a pleasure to introduce our panelists. Our first panelist is Professor Rupamanjari Ghosh, the Vice Chancellor of Shiv Nadar University. Professor Ghosh is a physicist by training. She received her master's degree in physics from the University of Calcutta and her PhD from the University of Rochester in the US, where she worked on quantum optics. She then returned to India and joined JNU in Delhi, where she spent the large part of her scientific career. And while at JNU, Professor Ghosh also started her work as an academic administrator. Among the many hats she wore at JNU, Professor Ghosh served as the Dean of the School of Physical Sciences there. Professor Ghosh joined Shiv Nadar University as the founding director of the School of Natural Sciences and the Dean of Research and Graduate Studies. And in 2016, she took on her current role as the university's Vice Chancellor. She serves as an expert on DST committees in physical sciences. She co-chairs the FICCI Higher Education Committee and is a member of the Council for IUCA and other organizations. Professor Ghosh is also well known for her efforts to support the cause of gender justice and environment consciousness in the higher education system. Welcome on board, Professor Ghosh. We are also joined today by Professor Ganesh, the founder director of IISER Tirupati. Professor Ganesh started his scientific career in the world of chemistry. He received his master's degree in chemistry from Bangalore University, and he has the unique distinction of then doing his PhD not once but twice. First from the University of Delhi and subsequently from the University of Cambridge, where he was a Cambridge Commonwealth Scholar. Professor Ganesh began his career at CCMB in Hyderabad and established a research group focusing on DNA-protein interactions. He then relocated to NCL in Pune and also went on to become the head of the organic chemistry division there. In 2006, he was appointed the founder director of IISER Pune, where he led several institution building activities to establish IISER as a brand for science education and research. He became a mentor director for IISER Tirupati and finally assumed full charge as the director. So now he has the unique distinction of also being the founder director of two different IISERs. We are very privileged to have Professor Ganesh here in our midst. Welcome, Professor Ganesh. And it is also a pleasure to introduce our third panelist for today, Professor Pradeep Kumar from the Rajiv Gandhi Center for Biotechnology in Trivandrum. Professor Pradeep is a life scientist. He received his master's and PhD training at Devi Ahilya University in Indore. He was a postdoctoral researcher at the Rockefeller University. He's also been a visiting faculty member at the University of Virginia and the University of Florida. At RGCB, Professor Pradeep leads a research unit focused on understanding the biology of cell division and stem cells. He's a very experienced mentor for his PhD students, and we are delighted to have him join us today to share his experiences with all of us. So I'd request Professor Ghosh to sort of, take a few questions to open the whole summit today. Professor Ghosh, we'd love to hear your views on the importance of the PhD scholar community for the Indian research ecosystem. Over to you, Professor Ghosh.
Thank you very much, Savita. Thank you for having me here. It's a really focused and deep panel. So yeah, it's a very good question to start with. Let me make some pointers, and I think we can probably go ahead and discuss in detail later on. So the associated questions people ask is, are PhDs only for geniuses? Do you really have to discover something incredible? Does the qualification make you an academic only? And higher research degrees are just for people who want to be academics. So so you can take it, you know where I'm getting with that. So my point is that a strong PhD program is necessary in every university if the university wants to contribute to what we call the knowledge economy and help take the nation forward. As you know, PhDs are your workhorse for research. In my university, we pay a hefty fellowship of 50,000 rupees per month, no tuition fee, single room accommodation and all of it, to put the emphasis back on research. Still, PhD students cost much less than full faculty, right? So, and it's a win-win situation. In your introductory remarks, you said very well how this is the training period for these young researchers to contribute to meaningful research later on. So in the Indian research ecosystem, you need the numbers to get steady excellence of a few. You know, unless you have a high average, you can't sustain those fragile peaks of excellence on them. So the numbers are necessary, and research is generation of new knowledge. So the question people ask, is it meaningful new knowledge? So, you know, that's where I think a lot of Indian debate today is concentrated on. So I'd like to just make a comment, and we'll come back later, that we need to combine priorities of abstract knowledge generation and excellence. So abstract knowledge generation and excellence, and what we call relevant research. We also need to contribute, link the contributions of science, research, and maybe innovation systems or invention systems with the inclusive economic growth agenda. So I think this you have to do while keeping academic freedom of faculty in mind. So more on this later, but for me, it's a question of leadership, planning and combining a top-down vision of institutional priorities with the bottom-up organic growth of faculty and PhD students. So the training in the PhD programs is designed to prepare people for research careers, either at a university or in industry. and which teach students how to discover new knowledge within their academic discipline. One problem I do see, and why your question is very relevant, is that it's almost non-existent R&D in industries in India. This has to change, and so more on that. So an emphatic yes to the question you're asking.
Thank you, Professor. So my next question sort of, follows up on something you just mentioned, which is, we are training a large number of graduate students in India each year. And as per the recent IISER report, we have seen in the last 5 years, PhD enrollments have increased by 60%. What are your views on this?
I'll take it in two parts. PhD has become a prerequisite for promotions of faculty in academia. Thus, a part of the increase, I would guess, this is the number of PhD enrollments, is actually mandated. So that part I'm not going to talk about. So my main take on this question is that even though numbers suggest a massive rise in enrollments, they are still inadequate as per the Indian aspiration, given the young adult population in India. So I think if you look at the hardcore numbers that came out in the IISER report, from around 1.17 lakh PhD enrollments in 14-15, we have just gone up to 2 point something lakh in 1920. This is despite having over 1,000 universities in the country. So if you really want research to drive the economy the way I talked about, I feel that this number is still quite small. And we should go for it because there is a lot of synergy between teaching and research. And universities should generate knowledge by researching and not just disseminate knowledge by teaching. So a strong PhD program is necessary in every university if it wants to contribute to what I just said, knowledge economy. So only thing that you can talk about is when there is such a scaling up, the quality and relevance of research. That has been a concern, right? So, but with the quality of research faculty rising in Indian institutions and the support and mentorship being provided to research scholars, even at the undergraduate level, the future for me looks promising. So I think the focus is again back on faculty. You need these mentors to be able to guide adequately, and excellence, there are no shortcuts to that. And quality faculty are not generated it takes a few years for generation of research faculty in institutions who would be the successful mentors of these aspirants, the PhD students.
Yeah, thank you. So we've sort of looked at, what PhD programs mean on a national level. Could I request you to sort of, talk about it from an institutional perspective? What is the importance of the graduate program for an institution? And why do institutions make all of these investments in graduate programs?
Yeah, I think even though, I look at university services in three parts. Teaching, that everybody says is your major occupation. I sort of differ a bit. It's research. And then third, I say service to your own institution, service to your professional community, service maybe to your society. It could be translational research and so on and so forth. So in all of this, one central piece that comes out is research. I just said that there's a lot of synergy between teaching and research. I want my undergraduates to be taught by the excellent researchers. Not all researchers are great teachers. So you have to have faculty development programs to bring them up to speed. But I think the learning that you get from a quality researcher is very different from somebody who just masters that and then vomits it out. So you lose that flavor, maybe that filtering that a researcher would bring to the classroom. So I see teaching and research going hand in hand. When you're a little blocked in your research, you go to your class, you teach, you hear these questions the students ask. Sometimes your brain just opens up and you sort of find a way. So I think it goes hand in hand. I'm giving only trivial examples, but it's much deeper than that. So teaching and research, for me, they go hand in hand. That takes care of two of the aspects. And the third aspect of service to the system where we are as an individual institution, I think that also gets enabled when you actually look at what kind of applications, what kind of translational research you can actually do, and then apply your theoretical knowledge to your society at large. So I keep talking about being global in our outlook, but deeply rooted in our context, local context. So for an institution like mine, which is really global, and if you know where we are situated, I really need to invest in such programs. If I don't, our undergraduates get, just gets an accreditation. They don't get ready for nuances of research and the unknown future in which they have to explore and find a way. Research prepares them for it. So I think having under one umbrella, PhD students, master's students, and undergraduates under extraordinary faculty with, of course, adequate infrastructure is a dream university that every university should aspire to be. So it's absolutely a necessity. It's not a fanciful thing. Research is not fanciful. It's an absolute necessity.
Thank you very much, Professor Ghosh. We have a few minutes left, so I was wondering if I could request Professor Ganesh to chip in as well. Professor Ganesh, would you like to add to anything that Professor Ghosh has already discussed?
Yeah, I'm completely in resonance with what Professor Ghosh mentioned. One of the most important thing is the faculty quality. I think she rightly mentioned, quality begets, quality. And unfortunately in India, except for few institutions, many institutions don't realize that. Faculty is the key for all the institution. You have good faculty, they train good students, they create a good environment, they're good opinion makers for the institution. So that's perfectly, what Professor Ghosh amplified. That's very, very important. The second element is the research element. That is very, very important, the research element, and particularly introducing, maybe I could speak a little bit later on, particularly at the undergraduate level itself, giving the, the research training to students. And I noticed that you're also Savita is also a Commonwealth scholar, and you also have a Cambridge University thing. And one could clearly see the difference in the training between, even in the abroad, the UK universities versus, Europe or even United States, US. We all got PhD within 3 years in Cambridge, as you know. And they entirely go for a simple idea. They don't go for real horsework kind of thing. Originality and idea, you have a small idea, you write it up as a thesis, you do some work, you get it. Whereas United States gives a fantastic training, 5 years, hard work, data. So there are different cultures in which, the research done. But the undergraduates of Cambridge University, in fact, when I was doing PhD, although I already had a PhD, attended a lot of undergraduate lectures at Cambridge. I relearned my whole of chemistry, again, by attending that. So they go hand in hand, as Professor Ghosh said, the undergraduate teaching, the researchers should be teaching, and the teaching should be doing researchers, That's very, very important. Yeah.
Thank you so much, Professor Ganesh. So maybe Professor Ganesh, I'll sort of ask my next set of questions to you. So you are the founding director of IISER Tirupati. You were the founding director of IISER Pune. And both these institutions have developed their graduate programs under your leadership. And please, could you share with us some of the, successes and the challenges of building these kind of programs in India?
Yeah. Thank you for that question. Somehow in India, the word called graduate program is not very popular. We have this, post-graduation we have, and then the PhD program. But conventionally, graduate program refers to the research, the PhD training, abroad. So I guess that's what we are talking about. And now I started at IISER, when I started at IISER Pune as a new institution, I already had, several PhD students guided at NCL under the auspices of Pune University. They all were affiliated to Pune University. That was fine because I joined in a system which was already happening. But at IISER Pune, when it started in 2005-06, the main thing was, even before I could think of research, the building, for doing research, you require laboratories. It is all a chicken and egg story. Unless you have infrastructure, you won't be able to attract faculty. Unless you have faculty, you won't be able to attract good students. So we had to start with the building infrastructure. And most institutions start in a small place where it is just minimally functional, which means that you can just do some administration. If you're lucky, you will have a little bit more office space, etc. And the same thing was true with IISER Pune, although we were lucky to have NCL provide some of its infrastructure. Leave apart, we had the land. So the first thing was to build the campus. And in fact, I must share this thing with not many people know. In 2006, I went about hiring almost 1 lakh square feet of a private building. Till then, it was very, very unusual or even not even known in government institutions to hire on rent a 1 lakh square feet of building space. I had to argue with the ministry the importance. If I do not have it, I won't be able to start the laboratories. And after all, the whole IISER concept was to train undergraduate student in a research ambience. So for that, I had to establish the research ambience. So by bending some rules, the ministry allowed, and that was a very, very big thing. And Pune, of course, we had a excellent ecosystem. Professor Ghosh also talked about the ecosystem. IISER Pune, within 1 kilometer of the radius, you have so many institutions, right from National Chemical Laboratory, IUCA, Pune University, NCBS, a host of defense laboratories. And that was very, very good for IISER Pune in developing the graduate program. We could place some of our students for doing research there. Those faculty could help us, etc. So, but the main thing is in the institution building, attracting good faculty and students. It is said in Princeton, a good faculty would join Princeton only because they get a lot of good students. And students would join Princeton only because they are the best of the faculty. So I'm not sure how many institutions in India, we have this, sort of dependence on each other, synergistic thing, students thinking about, oh, this is the place where we have good faculty, etc. So that is very, very important. But in a new institution, the most difficult part actually is attracting good faculty, because we have to compete with all the existing institutions. I'm sure whether it is true for either for private university or even for public university, because we had to wean away students and faculty, not wean away, we had to compete against established institutions. That is not very easy, because the IISERs, when we started, IISER Pune and Calcutta, we had to compete against, not, I wouldn't say compete, but we had to, in a way, what you call contra thermodynamics, in a way to work against thermodynamics in attracting faculty and the students. We have no facilities yet. Why would anybody would join? So the first 5 years was a very, very trying period for us. IISER Pune, Calcutta, and slowly Mohali, Bhopal, and then Thiruvananthapuram, the first 5 IISERs. We worked synergistically to build an image for IISER in attracting a lot of good faculty. One thing we could do was we could give them almost unlimited fund, which was not possible even in many established institutions. So that is the main thing. The second important problem in new institutions is that attracting senior faculty, because we get a lot of good people are coming back, the assistant professors level, there is no problem. We have plenty of good people coming back, but we require senior faculty. As you know, most of the people who become professors by 45, 50, they're already in a very comfort zone in many institutions, and relocation is not very easy in India, although probably things are slightly changing recently. People don't relocate from one institution to another institutions because there are family problems, children's school education, etc. This is again something different compared to abroad. So to build a good graduate program, the essentials of good faculty, infrastructure, laboratory, and the senior faculty, everything is very difficult. So entirely you have to use a lot of your energy and in promising people what the shape of the things would be. And also many faculty, they come. One of the important thing about the importance of the faculty is that you must hire them for what they will do in future. Because we all screen them, select them for the interview. That's all based on their earlier good work. But we need to put emphasis on what they're going to do in future and hire the faculty. So the end faculty, then the problem comes for a good graduate program. They've just done postdoctoral research work, etc. They do not have much teaching experience. So they are not much experience in including selection of PhD students. How do you select them? They do not have. So the senior faculty is very, very important in mentoring them, how to evaluate the students, because most faculty, when they join, they'll be very busy in setting up their labs. They're in a hurry to get to the research. They have no time for thinking about even imparting long-lasting skills or competencies in graduate students. They just want. Initially, they're under pressure, they have to publish paper. So they don't worry about a very healthy and a good graduate program. It's a combination of several things, and students and the PhD students, what we get, they're pretty good. They all come from competitive national examinations, etc. They have done a lot of coursework up to MSc. They have done very well. But when they come to PhD, still many institutions, they ask them to do certain coursework. In my opinion, that is not really required. 5 years, they have sat down, attended a lot of lectures and think whatever coursework they do, that should be more relevant to the actual research they should do. So we should engage them in a different sort of mentoring program right from the beginning for the research skills, rather than the generalized or specialized courses which they had to take. They must learn how to make the research relevant, working on such problems, and relevance in their own mini context, and how do you, for example, train them in good experimental skills? If there's an experimental, so the young faculty, I always tell them for the first 2 years, you must actually work in the laboratory. And first you train 2 of your students in good experimental skills, then further they would train others. Experimental skills, computation, critical analysis of results, presentation, oral, communication, how to understand the theory behind experiments, that's important. How do you keep record? How do you write a manuscript? How do you frame your ideas and convert them into viable proposals? How do you quantify your work? And these things are very, very important. I think in our coursework, somehow we should reorient, not emphasize too much on taking up more and more courses, but design courses which will actually be helpful for them in research. Putting that investment, you will actually get good finished students who are sort of all-rounders. And also a little bit of teaching of undergraduate students. In IISERs, the PhD students have to do tutorials for the undergraduate students, just like what we do in Cambridge, we're doing that. And we have to just make sure that they're not a pair of hands. And how do you do literature search, analysis? And also one must understand in new institutions, the different subjects have different cultures. This is the greatest thing I learned in establishing a new institution. Myself, I'm a chemist, but building an institution, I had to understand the physics faculty, the biology faculty, mathematics faculty. Their cultures are different. Their requirements are different. Their philosophies are even different. So if you want to support them, you must support in the same system. Like, mathematicians learn quite a lot, they're not like others. There's something a little bit out of the world, I think Professor Ghosh would probably, comment on that. Again, same thing in biology, same thing in physics. Their approach to research itself is different. And in addition, as they progress through the graduate program, what is this graduate program? We have to equip them to get into their future life or career. So they also require, for example, what is the importance of intellectual property, plagiarism. And the most important thing, which we don't play much emphasis on, those who are working in laboratory, safety of the laboratory. Not only laboratory safety, personal safety on the campus. You must be moving around the campus without any insecurity things. Ethics are important, integrity. And in addition, you should also sensitize them at that point itself about gender, diversity issues, etc. So if you want to have a good graduate program, I'm not saying that you have to bring all these things so that they become good future citizens. So in the new institutions, neither you have the faculty nor the ability to do all that thing. So, but you can always collaborate with others until we train the faculty, and then we have to train the students. That is the biggest challenge we have. And of course, it always mounts a kind of quality research, you have to have publications, etc. The first 2 to 3 years for a new faculty in any institutions is a tough period. They come back after a postgraduate program, they have to learn to teach, they have to do research, they have to train their own PhD students. In addition, as they build up in a large, if when you have 5-6 students, the faculty must be able to address the sociology of students. You get a different social life within the laboratory. So the faculty needs experience in handling all the things. So the real graduate program, you have to address not only the students, but also the faculty. I just take another 30 seconds. Most institutions abroad, good institutions are equipped. They have specialized departments to impart in each of the above abilities, whether it is IP or English, language, communication skills. They are done in the other departments of the university. Still, unfortunately, we do not have that. Maybe some of the IITs have those facilities, but many institutions, we do not have that departmental structures other structures to train students in a professional way. So each department does it in their way. So it is not really a very, done in a very professional manner. Even older IITs, some of them have a sound system of graduate training, but they lack appropriate skill stack. I have a lot more things to say about graduate school. Maybe later on, I will come back to that.
Thank you very much, Professor Ganesh. So maybe we'll just go to this point that something that the IISERs are particularly good at, which is nurturing a research mindset from a very early stage in the career. So could you share your perspective on the importance of doing this?
Good. See, the IISERs, when they were established, they were not just like another degree awarding institutions. A lot of thought went into what are the gaps existing in our present, graduate, undergraduate programs, and even in the postdoctoral things. So what was realized was they were thought of as a 5-year integrated BSMS degree with no exit route. So we do get students from all disciplines, chemistry, biology, physics, from the state boards, IIT, JEE entrance. So our pool is much larger. So we get a lot of students. We get students who have not studied biology. We get students who have not done mathematics. So the first thing which was done in IISER system of education was the first 2 years to bring a uniformity, to bring them all into the same level field. And how do you do that? So we introduced courses in all the areas: physics, chemistry, biology, mathematics. For example, how a person who's studying biology, how much of mathematics that student requires, how much of physics or how much of chemistry. So there was a very nice curriculum committee which went into all that. We never followed any models. We wanted to create our own models. So the syllabus was designed in such a way that, what is the minimal thing which is required? Concentrate on the depth of science. So that will help the interdisciplinarity later on, which is the challenge today, is the interdisciplinarity. If they have studied these subjects well enough in the first 2 years, they're not afraid to jump into another area. But that is not good enough. So the next 2 years, they're taught depth of science. They take advanced courses. After 2 years, they decide what they would like to become. They would like to become a chemist, biologist, physicist, mathematician. So they take advanced courses. But they also have the flexibility to take courses from even other disciplines. So the first 4 years, so the breadth of science, the depth of science, 2 years, and finally in the 5th year, they do entirely a research project. They will do it, it's almost like a PhD thesis. They have a proposal, they write a thesis, they do full-time research in the laboratories, or theoretical research, computational. They can even do research in any other institutions, need not be in the same IISER. So the BSMS program, when they come out, they're very well grounded in breadth of science, the depth of science, and interdisciplinarity, and also the research thing. In addition, the most important thing is right from the first year, we were asking about how do you inculcate research thing. In fact, the students, they never go home. In the summer, they hang around, they get attached to a laboratory every summer, 3 months. They actually join some faculty, learn some basic techniques. In fact, today, a 5th-year research student in IISER is almost equivalent to, I may be a little bit exaggerating, equivalent to a second-year PhD students. Because by the time they come to the 5th year, they're already very well versed with, many of the research techniques. And also one term they spend in physics lab, another in chemistry. So it gives them a very good choice, an informed choice of what they would like to become. So they get plenty of opportunities earlier to get into the research mode. And that is one of the biggest advantages in the IISER system. I'm sure a few other institutions are also imparting it, but here our curricula is developed, towards that. In fact, many times, even 5th-year students, by that time, even in the 4th year, some of the students have even published papers. So they get the thrill of it. I always say that for researchers, of course, we enjoy several things in life, but the day on which you get a mail saying that your manuscript is accepted for publication, the kind of happiness it gives is really enormous. In my opinion, I can't, meet that happiness from any other source. And the students experience it even before they're undergraduates. So by the time they pass out the 5th year, they already have all the rudiments of, the research, and also they do, bit of tutorials, etc. So that's the way we train them to get into research cultures. In fact, even today, the statistics says that more than 65% of IISER students, or 70%, they go up to research. In fact, we are asked these frequent questions about their, placement. And we don't like the word placement at all in IISER, because it is not for job. We are not training students for the job. In fact, one of the things I used to tell the parents in the very first year is that they used to ask, how much salary would my student, my ward will get at the end. I said, if you want to make money, there are several other ways of making money. Here, you have to just work with passion. I guarantee you only one thing in life, that is insecurity. You have to come up on your own. So the 5 years gives them very good experience and all-round experience, including the research one. So ab initio thinking, some bit of problem-solving skills, all these things they learn, even early stages in the first 5 years itself.
Thank you very much, Professor Ganesh. I think now we'll move on to Professor Pradeep. I have a couple of questions for him. Professor Pradeep, welcome. And, so the first question we'd like to ask is, during the course of your career, you have mentored several PhD students. So could you share with us some of the joys and challenges of being a mentor?
Yes, Savita. So I started my career immediately after my PhD in a state university, Devi Ahilya University, University of Indore, they used to call it those days. So, the universities are primarily, as Professor Ganesh also told, are organizations to teach, they have to run their teaching program. So there is no major emphasis on research. So essentially you are going to be teaching. And in that kind of environment, you have to start a lab. So you get a little space, you get 500 square feet of space, and you have an office space, and that's it. That's what you have. You don't have the funds. And then you want to run a lab, and you don't even have the experience of mentoring PhD students, because you were doing PhD till yesterday, and today you are a mentor, you're on the other side. So I thought, hey, what to do, how to do the things. So I moved a couple of grants, and the grants would take its own time to come. But I thought I will hire 1 or 2 students. So I do remember how I took the first student. I advertised the posts of 2 junior research fellows. So the JRF came in. Am I audible?
Yes, yes.
Oh, yeah. So the JRF came in, and a couple of them came in, and we selected 2 students. So we sat around, and I talked about what I would like to do and what I would want the student to do. So the age difference between me and the student could be like 5 years, 6 years, that's it. So you don't look like a mentor, you look like a student, in fact, so your student sometimes looks like the mentor, the faculty. So we sat across the table, we talked about what we wanted to do. This boy, a Bengali guy, and Bengalis move around everywhere. So very intelligent guy. So, well, we started off. It was a little bit about membrane biology, membrane biophysics, movement of molecules, within the membrane. So we had the machinery. Luckily, this Devi Ahilya Vishwavidyalaya had a nice machine to look at the membrane structure, which was very good. Otherwise, you have this little lab, little space, nothing else there, some table and chair, that's it. You have to buy everything later. University is not going to give you a startup grant also. So, so the student looked around, there is nothing visible, but there is an equipment which will let you study membrane. He joined me and we started. So, and then more students joined in later with their own fellowships. And then one day I told this boy that, okay, let us do this experiment. He looked into my eye and he told, I will not do that. He told in Hindi that, okay, well, I mean, maine karega. So his own Bengali Hindi, he told he won't do it. All other people looked at me as to how I'm going to react, because I'm giving him an experiment. He says he's not going to do that. I also was shocked for a moment, taken aback, but I thought all right. So I smiled to him. So he thought that I'm kind of disappointed. Then he pacified me. He told, no, I will do it, but not right now. Later I will do it. So and we started off with that thing, and then I moved a couple of grants, and I started getting grants. Getting grants was another interesting thing. You go to Delhi because you have to write the grants. They might call you for a presentation. You go over there, and you are a small fry. You are just an assistant professor, a lecturer. Maybe you are 27, 28-year-old, and nobody takes you seriously. And so they look at you, you ask for money, and they think, this guy, can he do this? I had publications and all that. But anyway, I still remember the DST committee, before which I presented my first grant application. They gave me huge money. When the money came, everything else was fine. There more students will come. They know that this guy has funds, and so you buy equipments. And a university laboratory looks, very dull, and nobody likes dull laboratory. So you have to do a little, facelifting. So you beautify the laboratory, make it look like a nice laboratory, and you attract students. Students come in. So this boy did amazing work. We had 7 publications from his PhD. He took 4 years to do his PhD. So that was a beautiful experience with my very first student. Very, very dedicated student, and he's a professor in one of the Indian universities right now. So I had fun with a lot of my students, and I, in fact, had a lot of girls in my laboratory. I realized, little gender bias over here. So looking at the way I could mentor the boys versus girls, and the boys do good work, but the girls are really, really more dedicated. Their hands are far better, so they are more accurate in executing experiments. So I had fun with boys and girls, but I do think that my girls were far more productive than my boys. So altogether, it was amazing. But I would say that in India, we have a vertical divide between the universities and the so-called research institutions. Universities become teaching organizations. Research institutions are research institutions. They don't do teaching, but there are a couple of exceptions, including, Indian Institute of Science and this new generation IISERs, and some IITs now have a biology program. I am a biologist. So earlier they did not have a biology program. IIT Kanpur is the first one to start the biology program, the research program. So I mean, the entire culture over there could be very different. But Indian universities, state or central university, they have more emphasis on teaching, graduate, undergraduate, postgraduate teaching. They do research, but a lot of their time does go in teaching, but that's a good thing, because you are primarily a researcher. You are going to teach in a very different way, and that's really, really good. The students enjoy that sometimes, and sometimes they don't like it, but many number of times they enjoy that. So you can really give a new dimension to teaching when you are doing research. And the institutes have funds to startup grant, as Professor Ganesh told. You can give startup grant to the new faculty coming in. He can set up a lab. But for a faculty in a university, even in the central university, there is no startup grant giving culture at all. So he really tries very hard, to do his research. It's almost like your hobby. It's not a thing that you are expected to do. But now with UGC telling that you need to have a PhD, you need to have this, that, as you said, that 60% increase in the PhD enrollment, it's only to satisfy the rules. You need promotion, which is not a good thing at all. You have to do research because you would want to do research. It's passion. It's passion. Passion should be rewarding, of course, but because if there is no rewarding for pursuing your passion, then passion alone is not going to fill your tummy. You need to fill your tummy end of the day. So it's very good to say that, okay, well, you are passionate about doing research, but at the same time, there has to be a system which is supporting your pursuit for going after your passion. That's what I think. So, and the bad thing, the bad experience that I had was that obviously a lot of good experiences, and that can be a bad experience. And the students generally are good, but then there are issues also. So I had this one individual. So she worked with me for 3 years, and she told me that I need my PhD. And in India, it's very difficult to give a PhD in 3 years' time, because there are a lot of hurdles. Grants come late, and reagents come late, equipments come late. So there are a lot of issues. You need minimum 5 years. So I told this girl no. So she said that, no, I need PhD right now. And she changed the supervisor in half a day. She influenced the system. She went to another supervisor, got herself changed. In a week's time, she got her PhD with the work she did with me. So that also is there, yes. So you do have good and bad experience in guiding students, yes.
Yeah, thank you very much, Professor Pradeep. I'd just like to now ask, so we've sort of looked at the importance of PhD programs for the country, for an institution. Would you like to comment on what it means for a PI? What it means for the research program from a particular group?
Okay, yeah. So it's very important. And when I moved from my state university to RGCB, which is a research organization, well, in Baby Ahilya also I did good research. That's a different thing. So everything is about research, and RGCB, because we are a DBT organization, we were not having any teaching program. We did have a PhD program. We did not really call the PhD a teaching program. So it's all about your research programs. So we are funded two ways. We have an intramural granting mechanism. We have an extramural granting mechanism. We are accountable. We have an advisory committee on top of it. So the advisory committee obviously would be looking at what you did, what research you did. So yes, for me, my research grants, I had grants from all the agencies. The work that I did using that money that I got from the government of India's agencies were very important for me to move on in my career. All the growth that I had in my career, it was because I was very consistent in generating grants. I was very consistent in producing PhDs. My PhDs were very productive. Each PhD went out with minimum of 2 or 3 publications, reasonably good publications in cited journals. And I don't really worry too much about the impact factor. It's about the science, the content of the paper that matters. So the scholastic value of the manuscript. So they all had grants, but they all have publications. When you have publications, on that basis, you will get grants. If you don't get if you don't have publications, you are not going to get grants consistently. So my PhD students were very much there for me to succeed as a PI. And my success as a PI had been the major reason how I could succeed in my career. Yes, it was very, very important. Yes.
Thank you very much. So I think maybe now what we'll do is that we'll request Professor Ghosh and Professor Ganesh also to turn on their cameras, and we'll have a couple of questions to all of you as a panel. So I think the first question, maybe Professor Ghosh, I'll request you to take this one as well. How does one measure success in graduate research? Again, at different levels. And research output is increasingly being used as a key determinant of sort of how institutions are perceived globally. So how does one measure success?
Oh, excellent question, actually. So I'm slightly old-fashioned in this, and so you have to bear with me till I complete the argument. Okay. So quantifying excellence with numbers has an inherent problem, and so the world is going crazy with like you just heard Pradeep Kumar, journal impact factor, citations. Citations take time to build, but if you really want to quantify excellence with numbers, it cannot be done. So the one side I can tell you that the flip side of it is that all formulas can be gamed, right? So you give me a formula, I'll crack it. I'll figure out how to actually be on top of it. That doesn't serve anybody. And I think so that's why all these malpractices that you keep hearing about is all over the world, self-citation, citation by friends, collaborations of, insignificant collaborations really, and so on and so forth. I would not name all of it because you have a lot of PhD students in the audience. I don't want to demoralize them. But the moment you attempt to do something that cannot be done, this is what happens. Now, the world over, it's going like this. So I tell you what I feel. I feel that in the research community, we as researchers cannot give up our responsibilities as evaluators. Many times you need subjective assessment because, the results is not really known. Earlier days, to tell you an old example, 1960, the laser was invented, right? Because you mentioned that as a quantum optician, quantum information processing and all of it, all of us used a laser. By the time I hit the US, late 80s, the laser was in the supermarket. But in 1960, when Myman made it, everybody said, oh, great, this is a good fundamental tool, but what is the use? So it took about 25 years for a fundamental tool to become an applicable tool everywhere. So that time period from proof of principle experiment to market tool, that has shrunk now. That's thanks to the advancement of technology. So it's no longer 25 years, but still there is a lag. And because there is a lag, often you cannot quite judge the importance of a research. You cannot quite judge the success of it. And you have to use your intuition and your knowledge and your experience as a researcher to be able to evaluate. It's no longer the search for truth, right? Gone are those days. But a pat in the back for a fellow researcher to saying that this is a very good paper, it's an excellent paper, that's sort of our judgment call. And I think it has to be done. It cannot be really done. But having said that, I must say that we cannot hide, mediocrity cannot hide behind this argument. So you cannot blame the system, and you can say that numbers don't make any sense, so I'll keep on publishing in low impact factor on unlisted journals or whatever they call these UGC recognized journals or whatever, and continuously defy that. The other problem is that if you measure everybody, that is institutional ranking, which PIs contribute to, that everybody is looking at, I have become an institution of eminence, so ranking has become a game, and we are playing that. But I'm playing it with fully knowing that this is not to be done the way it is being done. So if you do by, measure excellence by ranking with uniform parameters, uniform metric, that makes universities risk averse. I'll just trade the known path because I won't take any risk because my ranking will fall. It would stop also growth catering to contextual issues because those have no bearing on your global ranking. So this goes against the point I made earlier about being local, which this country definitely needs, research needs. So I think rankings and all of these things should be given back to the universities. There should be several ranking metrics, if you like, and an institution should be able to choose the one that suits its journey. Because it's not so much where you are in absolute terms, but the slope matters. What exactly was the mission of my university and how well I have done, I have fared vis-a-vis my own mission. That's what matters. Moreover, I would say that the future belongs to collaborative systems. So universities, as we talked about, three of us did not consult each other, but we are basically saying the same thing in the first round, as you noticed, Avita. So, there should be, we need partnership, national, international, industry, academia, which is not happening, private, public, which is also not happening much. But though with IISER Pune, for example, we have signed an MOU for science research and student exchange and faculty exchange. But when you have such an ecosystem of partners, I think it's only the universities that can be the quality controllers around it. No other entity can really do this. So I think you have to take that responsibility of doing it on your own. And when you have an understanding of what research entails, what is your priority, and what is, and don't make systems risk averse. The last point, maybe I'll say something else. I still believe some kind of accreditation or quality assurance is necessary. That's a baseline for all institutions. Baseline is the minimum standard. You don't, measure excellence by it. Don't bring your peaks of excellence back to the baseline. That's not the idea of regulation. So self-regulation should be the way, but accreditation is necessary so that our students do not get fooled when they're choosing what institution to go for. But I think we need to a lot of talk on that. And my very important point in this, I've been talking about it for some time, that I make a distinction between innovation and invention. Maybe it's not a play of words, really. Innovation is tweaking of some parameters, and there is a commercial sense to the term now. I think for innovators, you don't really need to come to the universities anymore. You can get a 3-month or 6-month course in some skilling, and you can actually probably do follow your passion that way. But what I call invention is a product of education. This is applied research. And I think the invention can link up to the country's economic growth. So the question we should be asking country-wise, because you also ask nationally, what is the invention the world and the country waiting for? Is it really a social media algorithm? Or are you thinking of flying cars? Or are you thinking of the sustainability problem? Are you thinking of the inadequacy in our healthcare system? Are you thinking of the cost of energy and food? So I think sustainability should be topmost in all of this, and the country should have an agenda for that. So you start at the national level, break it down to the institution level. Each institution can find it. Not everybody doesn't have to do the same thing. I think that's where the problem starts if you have ranking the way we are going for it. Well, I'll stop right here and interested in hearing others what they have to say about it. Thank you.
Professor Ganesh, would you like to add your thoughts to that? Also, in another slightly different context, which is interdisciplinary research, we are hearing a lot about this right now. There's a lot of emphasis also on sort of academia industry partnerships, which bring different kinds of research cultures together. So how does one measure success in these kind of collaborations where there are very different ways of functioning?
Yeah, Thank you. To add to what Professor Ghosh very rightly mentioned about all these metrics, etc. I'm not advertising this. I've been reading a book. I'm not sure whether you people could see it. It's called The Science of Science. It has just appeared. The very first chapter, I'll just take 1 minute to read how this, the paragraph starts. It says, the science of caring. Albert Einstein published 248 papers in his lifetime. Charles Darwin, 119. Louis Pasteur, 172. Michael Faraday, 161. Simon Dennis Poisson, 158. And Sigmund Freud, 330. Contrast these numbers with the body of work of Peter Higgs, who had published only 25 papers by the age of 84. Who got Nobel Prize for the boson thing. When he received the Nobel Prize for predicting the Higgs boson. Or think of Gregor Mendel, who secured an enduring legacy only with 7 scientific publications to his name. So the differences show that in the long run, what matters to your career is not productivity, but impact. I think this speaks for the numbers. Today we are mired with all these, numbers, NRF ranking, you improved by 0.2%, 0.3%. I think Professor Ghosh rightly mentioned that each institution is set up with a different purpose and a mission. And we have to assess them in those missions. One size does not fit all. And even today, when the world rankings come, Oxford, Cambridge, all these which have been in existence for 800 years, 1200 years, they're still competing in the top, but the top 10 universities never change. They only go one up, one come down, etc. When that is the situation, it takes a long time. I know IISER Pune, we started in 2006, and now IISER Pune has completed 15 years. Now they're able to little bit come somewhere in the international scene in terms of publications, etc. It takes a long time. Now, at least among the IISER systems, about 15 to 20 students who got trained, they have come back, they have become faculty in other places. IISc is 100-year-old. That is the biggest institution we have. Or you talk about Calcutta, IISES, etc. So it takes a long time. You cannot do that thing in 5 years, 10 years, not even in one's lifetime, But you have to build that culture, you have to build that ambience, and that is important. Numbers are important for those people who don't understand science. If you understand, science by nature itself is subjective. I do my science, I'm subjective, I interpret the results. And so by nature, it is subjective. You cannot eliminate subjectivity. And to put them in numbers, to some extent, it is fine. Not, it doesn't mean somewhere you have to draw. But we have to understand how they're contributing for the purpose of the mission for which they are established. And I think Professor Ghosh also gave a very nice difference between invention and innovation. I think it takes a long time, but our expectations are today you find. So what is important is sustainability for any education institution. Sustainability in terms of faculty, sustainability in terms of funding. The biggest problem in India is there is no sustainability of funding year by year. This year you will get it, next year they will chop off. There is always a permanent thing about particularly government thing, 20-25% cut. Now we have this thing. So you're given the budget of a small university and they want you to become Harvard or Cambridge or Princeton. That's, for everything we have to pay a cost, which government is not realizing, government or anybody. I think I'm glad that there are certain private universities, Shiv, Nadar, Ashoka, Kriya, they have all risen to that. They are putting enough money because if you don't, for everything, this excellence has a cost. Unfortunately, nobody believes that in India, So anyway, that is for that one. Now coming back to industry academy interaction, I got trained in NCL, which is a lot of industry interactions. Being a chemistry laboratory, we had lots of sponsored projects, etc., etc. It is very important. So I grew up in an atmosphere where a lot of industry partnership was there. But for new institutions or even for other academic institutions, it is not very easy. Because basically there is a problem in India about industry and academics. Each one have not fully respected what the other ones can contribute to that. What has happened is that industry, they are the end users of academic products. We all produce graduates, they use them and they get it free. They don't pay anything back to the university, right? They get it, but even then they complain that they have not been, their quality is not very good. When I was in IISER Pune, I tried to involve pharma industry, polymer industry to come and give lectures, to take courses, to even to design curriculum so that our products will be suitable for them. But they don't have people. They don't come back. They don't come to that. So there is a very, it's only, they think that the academics ask, industry some money for, but they don't realize the kind of end products what they get, they have to give something back to the institution. In fact, once I had a very crazy idea that every time an industry hires a graduate, some X amount of money they have to give to the institution where the student has graduated. You apply this simple formula, academic, institutions can raise a lot of money. Number of universities that produce so many things, put nominal. Like IITs, they say you give $100, that's good enough. But when you have a large number of students, it becomes a very pool. So that is one thing. The second thing is industry wants ready-made products. They want off the shelf, then only they will come, which is not possible either for the universities, institutions, or to the even national laboratories. We have Pradeep Kumar from Rajiv Gandhi, Center for Biotechnology. We cannot give them ready-made products because products ultimately it is used by the society. Scientists in the laboratory, we do not have that knowledge of how the product, your product may be entirely good, technology, everything, but you do not have the knowledge about the social aspect of it. Technologies will fail. Many good technologies, there's nothing wrong, but they did not tune into the social behavior of people. So that is where the humanities and social sciences have to get. Industry, they have a knowledge. What kind of product, what kind of end user, what is it they require. Now, unless they give that right in the beginning of the project, then there is otherwise academics, they will make something, put it in the shelf, but it will not be useful practically. So the industry academy interactions have to be developed right from the beginning at the entry of the project, even in the DST, DBT, etc. We always talk about that. Only those projects where industry has entered into the early stages of a project, they have succeeded because they can tune the project from the end user or for the translatability of the thing. So it takes a long time. You look at Europe, Switzerland, particularly pharma industries, academics. You take United States, every assistant professor, even he has a chair. In addition to the job, he may get some $2,000, $3,000, but he has a name chair associated with it. Industry feel very happy to be associated with any institutions. But today, we don't have that situation in India. Only maybe IITs have some chairs, etc. But the philanthropic attitude of industry is one. The second thing is the business aspect of it, trying to come make use of that. We have a long way to go. And whether it is, for example, Reliance in energy, I should not take the name of the industries, but now today there is so much of energy. How many institutions working in energy are being really, the industry is participating in that? Very, very few, whether it is nanomaterials, anything, and the basic R&D setup is necessary, industry. And, it was mentioned that industries lack R&D setup. That's a problem. So finally, what I would like to say on this account is that I know in several universities abroad, they appoint, it's not that all the research happening in universities is trash. It is not like that. All the many universities, I know I have visitors like that, they all appoint retired industry consultants whose job is to go and talk to the faculty and convert that idea into something useful. That is where we lack. We may do some work, but we don't have, many academies don't have the knowledge of converting that. It's entirely in the Western system, anything they invest, they will make sure, the idea, they not only that, they market it in such a way that the product becomes a success. We lack that ability. Not that all, I think, in fact, by industry, this consultant, he goes, talks to all the universities, all the teachers, they don't ask them to change their work, but they will translate it. Okay, this guy has done this thing, how this can be used. Now, that kind of inventive ideas, we don't have that. So unless we, to some extent, pharma, it happened probably. I'm not sure how much it has happened in IT. IT only takes students, etc. Now data science is coming up. They say that yesterday I read that, so many lack of data science people, but about 2 weeks back, Nature published an article which said that in 5 years, data science people will all be useful. As AI comes in, data science goes away. So in this changing world of importance, we also have to, but industry, I don't know how to break the ice between academics and industries. I think to some extent, IITs have done that, but not much has happened in the universities. And universities are our hub, unless we change the character of a university, bring all these elements. And again, it all starts with faculty. Only merit should be the sole criteria. If you appoint people with little bit of other, whatever the social aspect of it, that has to be given not by any other considerations. So India has to mature quite a lot when it comes to industry academy interactions. We have a long way to go. Learn from them. We have just started maybe a bit of startups. That is a good thing. Entrepreneurship is starting.
Thank you very much, Professor Ganesh. I think we'll start taking some questions from the audience. So we have a question, which is, what are the panel's suggestions on enhancing the quality of PhD graduates in the country across all levels of educational centers, not just the top institutes? Maybe Professor Pradeep, I'd request you to take that first. How can we enhance the quality of PhD graduates all across the country's institutes?
It's all about getting the right people, the best people possible. It's almost like cooking. You can make an amazing dish if the ingredients are really good. Today, the people who are coming in for the PhD program, I would not say they are the first-rated set of students. The first-rated set of students go for other courses, unfortunately. In majority of situations, that's what happens. I'm not saying our students are bad, they are good, but they are not the best ones. How to attract the best students to make the PhD program the best in the country is a question. So to make that possible, everything has to become attractive. The fellowship has to become attractive. The salary that they can get, when they get their PhD should become more attractive, because they are spending long years after their masters to do their PhD. If they don't get rewarded in later life for what they did, then they will have 100 other things to do. As Professor Ganesh was telling, somebody's parents asked, okay, what will he earn? How much will he earn? This is a very relevant point. All the young people today would wonder, how much can you earn? So the first thing is the government should really think about enhancing the remuneration that the grad students get in India, and also the funding. The PhD students, the fellowship they have, along with the fellowship, the contingency grant that they get is 20,000 rupees. And can you do PhD that 20,000 rupees? It's true that the scientists generate extramural grant, and these top institutions, we do have intramural grant. But think about the universities, which are the hub where the majority of the students live and grow. There is no money there. You have to put in a lot of money, and you have to attract the best of best that you have in the country. I would say, I had written also on the Facebook that we may have to really think about enhancing the remuneration that the PhDs can get in the country. That will attract the best students into the PhD stream, and also they will continue their activity in research. Otherwise, they will go to something else. So I would suggest that, yes, the financial package for the PhDs should be enhanced considerably.
Thank you, Professor Pradeep. Professor Ghosh, would you like to add to that? Actually, we have a question specifically about private universities. What can private universities do to attract good students?
I'll combine the two. It's a good question. Thanks for that. My take is slightly different. The situation in the country has changed. Earlier professors' children were not aspiring to be professors. Of late, I'm seeing a change. My ex-colleagues and friends, children are actually coming to the university for research. And research, they get first exposed like IISERs at SNU also, you get exposed at the undergraduate level. It's mandatory in the curriculum, all undergraduate programs, BTech to BMS to BSc research, they're all 4 years, 1 year is there. But outside the curriculum, I have floated a program that I very fondly call our program, OUR, Opportunity for Undergraduate Research, where for 2 semesters, they can pick up a mentor anywhere in SNU, and I give them a small budget for that, very small budget. But it's not a compulsory one. They don't get any credit for it. There are some filters as well. More than 100 projects run. And really, this has become a differentiator. Once you experience some of them, when they get an excellent grade in our project, they have a fast track entry to our PhD program with a hefty fellowship, paper presentation in conferences, all fairs included, etc., etc. It's not like we are flooded with money, but I think you have to set your priorities right, where I want to spend that money. the culture has to grow. People have to understand that PhD, because there is a lot of questions, right? I mean, it takes long. In India also, average is 5 years. And after that, it's uncertain what exactly are you going to do. We get hundreds and hundreds of applications that we simply throw in the garbage because they don't make a cut for our kind of faculty. But I have never seen a good PhD not getting a job in India. So I think people have to understand the constraint on quality, and this is what the country needs. Institutions are understaffed, so we are looking for very good PhD outputs from our system to take up these faculty positions. What we need, what I already had hinted at that, is that faculty is your key. Particularly in science and technology research, it's really terribly mentor dependent. A supervisor has to it's not so in my social sciences school. You have terribly bright students. Most of them formulate their own research problem. In management also, I'm seeing a little bit of that happening. But in science and technology, you need a lot of infrastructure, mostly if you're not a theoretician or not a deep mathematician. You need a lot of infrastructure. Your mentor has to bring in that grant, and your mentor has to actually guide you to what is a worthwhile problem to pursue. So I think I would put the thing squarely back on faculty. The entire ecosystem will actually thrive if our quality of faculty, our quality of the research goes up. And I think that's the clue, whether you're in a private system or a public system. And I think the quality control has to be done. You don't have the luxury of training students, the point I think Dr. Pradeep Kumar made. You don't have the luxury of training them for their class 12 onwards. So I think some of it has to be made up. But I do see that 18-year-olds are terribly bright, and we don't lack any human resources in this country. It's a question of mentoring them, channelizing them in the right way. And the onus is on faculty and academic administrators like us. I have a lot to say, but I'll stop here for now. Thanks.
Thank you very much. Unfortunately, we've only sort of scratched the tip of the iceberg. There are loads and loads of interesting questions, but in the interest of time, I think we will have to draw the session to a close. So I'd just like to ask one final question to all our panelists today, which is, how can technology be used to address challenges in managing PhD programs? In your opinion, are there any gaps that would benefit from emerging technologies, sort of both institutional or national context? Would love to hear from each of our panelists today. So maybe Professor Ghosh, you could take that question first. We'll just
okay.
One panelist.
Right. Yeah, I think it's good to be done first, then I can listen very carefully to what my co-panelists have to say. So I'll address it in two ways. One is the infrastructure, in which I also address what you're going to talk about tomorrow and what Savita, we had discussed a lot. The proper management of and support to the system. So the academics do not waste their time doing things that do not require their expertise and experience, right? So I think technology can come very well in doing, I'm not talking about only LMSs and those kind of stuff, but essentially putting a structure that takes care of management of research. But more importantly, my answer is an emphatic yes to your question that it is going to help, because it will be foolish to spend time and energy trying to do something that you can get done through an available technological tool, right? So I think that goes without saying. But let me say that two kinds of technology people often get confused about. One is the digital tech infrastructure support for delivery, right? I mean, it's a support system. That's obvious. Digital is a powerful tool, and we must know how to use creative digital tools to learn, communicate more effectively, etc., etc. So digital literacy is an enabler. So you can innovate, you make meaningful contribution and accelerate everything that you're doing. But there the problem, of course, is the digital divide that everybody talks about, and we need to be mindful of that. The second kind, though, is teaching, learning, and creation of digital technology. We have enough minds in universities who are interested in this invention or creation of digital technology. So, but technologies alone will not be able to solve all societal problems. AI, for example, will be a multiplier only when physical solutions are there. So I think we need to have our priorities well set. I'm not saying just because I'm a physicist. I mean, you cannot have liberal arts on one side and disruptive technologies on another side and forget hardcore basic sciences, because your solutions will come from this middle one. And then AI and all your disruptive technologies will be good multipliers. But you can't multiply 0 by any big number. It will still stay 0. So I think that we have to talk about. But yes, when it comes to infrastructure support, I'm saying an emphatic yes. I'm saying when it comes to development and creation or invention of digital technology, I'm saying make your priorities right. It's a yes again, but make your priorities right. And it can really help. It would be today, it would be stupid not to be digitally literate. I am learning in my age every day. So I suppose, everybody should do it. But then you apply your filter and say, okay, this is for me, because technology should not dictate the pedagogy. It should be the other way. Your pedagogy should lead to the choice of technology, because technology does limit. I don't want anybody to get limited because some fancy tool is available. So that's the summary.
Thank you.
Thanks.
Thank you so much. Professor Pradeep, would you like to add your thoughts there? I think you'll have to unmute yourself.
Yes, technology has really revolutionized the way we do science today. We have a high throughput technology to crack the genomes of any given organism overnight, possibly. We have high throughput proteomics, so we have huge amount of data generation capability. That's almost like a gold mine. We have huge data that can generate over no time. And obviously then comes the data science. You have to really look at the data and take out what you want from the data. And also there's huge amount of data available in the public domain. You can really make use of that. Our grad students are doing it, and they are doing it with more efficiency as time goes. All the equipments that we have and the technology that we use, that also is improving every single year. If you look at it, today we have the 3rd generation sequencing, next gen, NGS we call it, and we have the LC-MS/MS to look at thousands of proteins in no time. And then we have, as Dr. Ghosh told, we have artificial intelligence and the machine learning that is going on, which is overtaking the data science almost fully. And today we have this virtual reality, VR, AR devices, so they are really enhancing the program, the graduate program that we are doing. And the kind of connectivity that we have today in our country, we are a developing country, is amazing. Recently, we had a series of interviews, and these students were, in the parking lots, in the car, and they were, giving interviews. So we asked, okay, well, what are you doing? So they told, okay, well, this corona, and my grandmother is in the hospital, so I'm in the parking lot, but I can give the interview. It was not possible last year. We never thought that this is going to be possible at all in India anytime in future, but it's possible today. So I asked him, okay, well, whom do you thank for that? Because you are giving the interview from a parking lot. He told, okay, well, I would love to thank Ambani, because the kind of the data, the price of the data is so cheap in India. So he wanted to thank Ambani. So it is amazing. The future looks very, very bright, and we are becoming capable. Our science is becoming good. Our infrastructure is at par with what you have in the developed world, and we have bright students. We should get brighter students, and yes, we will have an amazing technology enabled that program, which will be improving every single day in future.
Thank you so much, Professor Pradeep. And Professor Ganesh, final words on the matter of technology.
Today, technology is like that. I would only put technology next to God, I think. We have to technologically savvy. Now, as Professor Ghosh also mentioned, it can be used for 2 purposes. One is mostly for management and infrastructure. Managing all the research students, progress, reports, theses, in the stores, purchase, chemicals, all these things, or laboratory, LIMS, management for the instrumental things, etc. That is one aspect. The second is the technology for research itself, as mentioned by Professor Pradeep Kumar. The 2 different aspects. And I think one of the things which our own generation has seen, the technology is mainly, let's say, in publications. One is, of course, I will not talk about research. High and high equipments are coming, everything is there. But as a common man, as an author, a research paper, how I was publishing 10 years back and how I'm publishing now, there's an enormous difference. Today at the flip of a button, you submit a paper and you get immediately everything, and papers get accepted or rejected. Everything, it is so fast. The knowledge is flowing, you're taking decisions so fast. In fact, when I became editor of I felt very happy when I rejected a paper from a mobile phone. I rejected a paper. I felt so happy, So yeah, the technology has really, and even including preparation of your manuscripts, etc. But there is also a flip side to that. In many of the biologists, we know how images are being manipulated in publications. There's the other flip side. Recently, I saw 2 papers in which the gel electrophoresis bands in the next paper, they simply inverted it. That's all, 2 bands, and we could see that. But also technology comes to, do all this, check all this plagiarism, etc., etc. But technology has played a very, thing. We cannot avoid that. And most important thing is, I think in the last 1 year pandemic, we realized the power of this technology. Earlier, you conduct a meeting, you go through Skype, a Skype ID, you get it, you spend so much time getting connection. But today, within 5 minutes, you set up a Gmeet, with 50 people, 100 people. And in fact, students can discuss all the things so fast. Of course, nothing can replace in-person meeting, but conferences, but the accessibility has become very good in that sense. You can, the other day, I think Ashoka University had a Nobel laureate, giving a distinguished speaker. 500 people attended to that. If it happens in person, where will the option be for us to hear that person? So the amazing thing, 1 year of pandemic has taught us a different kind of technological use, at least for the teaching. Everything, nothing is perfect. It's its own flip side, but it has added a lot of things. And we cannot, I think people who publish in biology, again, Professor Pradeep Kumar would know the kind of illustrations we can make to illustrate our concepts, biorender, ChemDraw, and with 3D modeling. All these things have given us an entirely new tool to understand the concept in a much, much better way, to simulate things, etc. So I think the technology has helped quite a lot in fast forwarding things. But finally, when it comes, you have to do experiment in the laboratory. Technology cannot replace it. Technology can help, it can automate a little bit, but the human element cannot be replaced. The mind cannot be replaced. That is the thing. But it has played its own fantastic role in forwarding several things, or even literature search. I must tell you, in our days, I think both Pradeep Kumar and Professor Ghosh, we used to go to the library and read journals, hard copies of the journals, flip, every page. So we used to get a lot of ideas, because a lot of things which you're not looking, you just get it through that. But today, what happens? You want to know something, you give a keyword, you will only get that references. There is no way in which, by what you call serendipity, we can get information, something else which triggers us. That's a sad thing. And students only look at the keyword, you only get those, you get thousands of papers, then you have to clean it up, the 90% is useless. But in our days, we used to do hard work, but we used to find so many things, when you're not looking for, you get the information, it used to trigger us, I'm not saying we should get back to the manual thing, but everything has its own flip side in the advantages.
Thank you so much. And it's with a very heavy heart that I'm going to have to sort of say, we bring this session to a close. A huge, huge thanks to all our panelists. And I'd like to invite Dr. Shanti Krishnamurthy, the president of AuthorCafé and the chief domain officer at TNQ Technologies, to join us. Shanti received her PhD from IIT Madras. She started her career as a material scientist and then moved to the publishing sector more than 2 decades ago. And she heads the R&D team at TNQ, building new products and technology services for the publishing industry. Shanti, over to you to tell us about AuthorCafé and its journey.
Thank you. 4 minutes left, so I'm not going to take much time. Good evening, everyone. Let me start by expressing my very sincere thanks to all our esteemed panelists. The panel discussion today was very interesting, very, very engaging and insightful. It's provided a very deeper understanding of the problems related to building and managing PhD programs. I think we have covered multiple perspectives as well. I also thank all the participants. A lot of questions, sorry we couldn't answer some of them, but thank you so much. Very small note about AuthorCafé, which is the product that we are trying to launch in this ecosystem and its parent company, TNQ Technologies. I also wanted to just touch base on the role we have played in this ecosystem so far and what we aspire to achieve further. TNQ Technology is a 22-year-old organization. We have been providing technology and publishing services to STM and academic publishers. I mean, we also cover right from a journal of religion to politics to stem cell to quantum physics, variety of subject areas we cover. So we are very privileged to work with publishers like Elsevier, Wiley, Cell Press, American Chemical Society, Royal Society of Chemistry, and Professor Ghosh, two of big physics publishers, American Institute of Physics and IOPP. We worked with multiple North American health science societies. So our headquarters is in India, but we have offices in London and Toronto. That's we as an organization. Our mission has always been to support Indian scientific community by leveraging our domain and technology expertise. This is something we are very passionate about. Some of you would have seen us in a TNQ distinguished annual lecture series, where we invite eminent scientists across the world and share their research and share how they did their research. It's not its journey is never a very toughy one. It is a tough journey for every scientist. So we wanted all our students to interact with them, and learn how they did their journey, which is one of the reasons why we run this lecture series. The last speaker was Professor Venkiramakrishnan. I'm sure we all know for his research in river science, a chemist who went into a structural biologist. Our next speaker is Professor Jennifer Doudna, the recent Nobel Prize winner for her discovery in CRISPR-Cas9 gene editing. We also promote Inspiring Science Award, one of its kind award for the best published papers from Indian Research Institute. This initiative, AuthorCafé, is very close to our heart. It was born with a vision to be a kind of small destination to help authors to make their paper submission ready. That's how we started it. Then we slowly evolved ourselves in the last 2 years to research writing, publishing, and solving some underlying problems of PhD program management for the institution. I was very happy when Professor Ghosh, Professor Pradeep, and Ganesh, when we were talking, you were particularly talking about students and how undergraduate students to get into the culture of research. I'm very happy to share a small case study. We have a long association with Indian Academy of Sciences, where they use AuthorCafé, and they published over 2,000 reports in the last few years. This is a program called Summer Research Fellowship. I have seen students from all your institutes working with the faculties, a lot of collaborators. So basically the program connected the undergraduate students, faculties, collaborators, and also gave a lot more transparency to academia. So this covered the entire research program. In fact, I've seen those reports published and people reached out to the students for those research. It was really a good small case study that we are very proud of. I think the discussion today has enlightened us with the structure of research, starting from the national to the institution to the individual, and all of you covered very specific issues that as an institution that you are coming across to build, maintain, and excel in the research program. It gives me a lot more satisfaction to see at least some of the key problems we were able to cover it in the product, and we will make a small impact to this ecosystem. So we are very committed to our vision of supporting Indian science community. I really look forward to organizing similar open discussion. We're also, Sarita and I were talking whether we wanted to take this and publish it in a forum, because I don't want this discussion just lying in air and being in YouTube for some time. We are really thinking about it. Thank you once again for joining us today, and I really look forward to seeing all of you in tomorrow's session.
Thank you so much.
Thank you all.
Yeah.
Thank you very much.
Thank you very much.
So on
Thanks, everyone.
Note, we bring today's edition to a close, but we have tomorrow's edition as well. So today we've sort of looked at the broader context of what PhD programs are for the country and for institutions, for mentors. And in tomorrow's edition, we'll take a deeper look at management of PhD programs and what institutions can do to actually support that. So you can use the same link and join us back. And again, we have another really amazing set of panelists. Look forward to a wonderful conversation tomorrow as well. So thank you all very much to all our attendees for joining. And of course, a huge thanks to all our panelists.
Thank you so much. Bye-bye.
Thank you so much.
Savita, thank you.
Thank you.
Bye for today.
Bye for today.
Bye.